humans are more closely related to dinosaurs than they are to octopuses. Our lineage split from that of cephalopods, the spineless class that includes octopuses, squids and cuttlefish 500 million years ago. Octopus brains lack any of the major anatomical features of vertebrate brains, and most of the animal's neurons are distributed across their arms rather than in their head. Yet octopuses are extremely intelligent, with a larger brain for their body size than all animals except birds and mammals. They are capable of high-order cognitive behaviors, including tool use and problem-solving, even figuring out how to unscrew jar lids to access food. Increasingly, some researchers are suggesting octopuses' combination of smarts and sheer differences from humans could make them an ideal model for inferring common rules governing complex brain function, in addition to revealing novel neurological workarounds cephalopods have evolved. Scientists have often turned to animals, among them Drosophila fruit flies, zebrafish and Cenorhabditis elegans nematodes, to gain biological insight and understanding. But of all the widely studied model species that are easy to raise in the laboratory, rodents such as mice have been most instrumental in understanding how the brain works. Using octopuses to gain insight into our species was originally proposed in the 1960s by neurophysiologist J. Z. Young. The idea moved within reach in 2015, when scientists sequenced the first octopus genome for the California two-spot octopus. A whole genome opens up huge levels of information you didn't have before, says Clifton Ragsdale, a neurobiologist at the University of Chicago, who co-authored the octopus genome study in Nature. Octopuses could also inspire biomedical engineering advances, which could someday lead to new technologies to erase unwanted mutations encoded in human genomes. Researchers have begun developing cephalopod versions of the same molecular tools that those working with mice or flies take for granted. Further research may let scientists insert activity indicators into octopus cells. This process will let them study the animal's neural activity in real time, says marine biological laboratory researcher Joshua Rosenthal, who co-authored the knockout study. Once we get that next step, he says, I think the community is just going to start exploding. Big-brain cephalopods could shine a light on the evolution and neurobiology of intelligence, complexity, and more, and inspire medical and technological breakthroughs.